This is Note Taking Guide 6.6 for mathematical decision making for life. Today we're going to talk about the distribution of data and box and whisker plots. Sometimes we just call them box plots, sometimes we call them box and whisker plots. They're the exact same thing, so whether or not your assignment says box plots or box and whisker plots, just make sure you're doing that same thing that I'm going to teach you today. So the first thing we're going to talk about is there's a couple of different types of data. The first kind of data we're going to talk about today is called quantitative data. Quantitative data is data that can be measured. So for instance, you would use a ruler, you could use thermostats, thermometers, you can measure feet, inches, anything like that, volumes, areas. So anything that can be measured is going to be quantitative data. The other kind of data is called qualitative data. Qualitative data is data that you use your senses to observe the results. So say I said, well, what's the most popular color of t-shirts on people in the store today? Well, you would have to visually see what color of t-shirts people were wearing that day. So you were using your eyes in order to do that. So qualitative data uses those five senses to find the data. So there's two different kinds of quantitative data, so data that can be measured. One kind is called discrete and one kind is called continuous. Now the difference between discrete and continuous is this. Discrete can be counted, like we know it's like 1, 2, 3, 4, 5. Continuous is different than that in the fact that it could be like, maybe to think about it, like random decimal point numbers or random lengths or in inches or feet or random. It is still measured, but we can't like use 1, 2, 3, 4, 5 to describe that data. So discrete again is like counting 1 fish, 2 fish, 3 fish. Examples of that are like how many test questions did you answer? How many students were in class? What's the number of this? Continuous, on the other hand, is still measured, but you don't know for sure what it's going to be at that certain point. So for instance, an example is the depth of the ocean in a certain spot, the amount of time required to complete a project, the height of a child, those kinds of things. They're all measured, but they're continuous data, meaning that the measurements will be different no matter what, depending on whoever you're looking at or what kind of thing you're doing. So we're going to look at these examples today and we're going to decide what kind of data they are. Is it qualitative, meaning it uses the senses, discrete, meaning you can count it, 1, 2, 3, 4, 5, or continuous, meaning it's a measurement that is going to fall in between some kind of area. So A says the color of shirts in inventory of a store. So color of shirts, that's definitely qualitative because we're going to use our five senses in order to figure that out. So A is going to be qualitative. B, it says the speed of a plane 2 minutes after takeoff. So that's definitely measurable. Is it measurable like 500 feet, 501 feet? Well, it's probably not. It's probably more continuous because at any given point on that, it could be anywhere between a spectrum. My goodness, I'm having a hard time spelling continuous today. Let me start that over. So continuous. So it would be continuous because of the measurement that you would get when you're measuring that. Okay, C, the time taken to solve a Rubik's Cube. Again, time is continuous. So we're going to go continuous here. And then D says the number of bedrooms in my house. That's countable. That would be like 1, 2, 3, 4. So that's actually going to be discrete. And then E, the gender of the members of a band. So gender is definitely qualitative because it's not measurable. Okay. All right. So now I'm going to introduce you to what a box plot or box and whisker plot is going to look like. So there's some important parts on this when we're looking at it. The very first thing we're going to do when we're making a box and whisker plot is find the median of our data, so the middle, and it will be the middle of our box. Then if I were to take this data or the rest of the data from the median up, and I found the median again of that data, then that median would be called quartile 3 or the upper quartile. And if I found the data from the median down over here, and I found the median of that data again, then that would be the measure of the lower quartile or quartile 1. So here's my original median. Here's the median going this direction. Here's the median going that direction. And then at the end, we have our maximum and our minimum values, which make the whiskers on our graph. The box goes from lower quartile to upper quartile, is called the interquartile range. So in order to find that interquartile range, you would have to find your quartile 3 value and your quartile 1 value, and you would have to subtract them. Let me show you how to do it in just a minute. It'll make more sense. But before we get started on doing a box plot, let's just remember what we know how to do. So it says use the data from 2016 to answer the questions. And then it gives us the number of students that were enrolled in our local high schools in 2016. So Desert Hills High School, Dixie High School, Hurricane High School, Pineview High School, Snow Canyon High School, and Mill Creek High School. The first thing it wants me to do is find the mean. If you remember, the mean is the average. So the mean would be to take these numbers right here, add them together, and then divide them by the total number of numbers there are. There's 6 different numbers there, so I'm going to add those together, and then I'm going to get my answer by dividing by 6. So take just a second, plug those in your calculator, divide that by 6, and get your answer. And when I do that on my calculator, I get 944.17 for my average or my mean. Okay, then the next question on here asks me to find the median. The median is the middle number. In order to find that middle number, though, I'm going to have to write my numbers in order from least to greatest. So I'm just going to start writing them. I'm going to start with 221, and then the next number would be 832, and then 1048, 1127, 1144, and then 1293. So there's my numbers in order from least to greatest. If you remember when I showed you guys how I like to do it, I kind of like to cross off the first number and the last number, cross off the next first number, the next last number, and then it shows me, because if I were to cross those two off, I would have no numbers left. Then it shows me there that that would be the number that I need to use to find my median. When there's 2 numbers in the middle, I have to add those together and divide by 2. So I'm going to take that 1048 and I'm going to add that to the 1127 and I'm going to divide by 2. That's going to give me my median. When I punch that in my calculator and let my calculator do that for me, I got 1087.5 for my median. Now, you guys, just to point out a fact right here, so that's not actually the middle of, it's not actually a number. The median is a number in between here, right here, somewhere in the middle of those 2 numbers. So my median is in between here. And that's important to note. So, because in just a minute, when I need to find my interquartile range, I'm going to have to find the median of the lower half and the median of the higher half. And in order to do that, I'm going to have to know where that middle point is. And because that middle point's not using one of those numbers, that means I've broken it up into an upper half and a lower half that I can use the numbers for to find my quartile 1 and quartile 2. So, all right, let's go on and finish the other questions before we go and do that, though. So the next question says find the mode. The mode is the number that occurs the most. There's not a number that occurs more than one time here, so we're just going to put empty set or no solution. Now, the range, on the other hand, the range is from highest number to lowest number. We're just going to subtract those. The highest number is 1293. The lowest number is 221. I'm just going to punch that in my calculator and subtract that. And when I do, I get the number 1072. So my range is 1072. Now this last one, this interquartile range, if you remember over here on this other side, interquartile range takes that median from the top half of the data and the median from the bottom half of the data, and it subtracts it. So that's what we're going to do here. So we're going to find the median of the top half of the data. So my top half of my data is those 3 numbers. So the middle of those 3 numbers would be 1144. Then I have to find the middle of the first three numbers, because again, my median cut it into two equal parts there. So the median or the middle of those numbers is 832. So then I just have to subtract those two together to get my interquartile range. And when I punch that in my calculator and I subtract it, I get the number 312. All right, that was a lot of work on that problem, but let's go on and see what else we need to do. So the next thing says, reminds us what an outlier is. An outlier is a value that is substantially different from the rest of the data. So then the question is asked, what is the outlier in the previous set of data? Well, if we look at the previous set of data, all of these numbers are pretty much in the same area. I mean, the 832 is a little off, but the one that's totally outside the area of those numbers is Mill Creek High School, which is the number 221. So it would be considered an outlier in the set of data. Okay. All right. Next question. Make a box and whisker plot for the set of data. Now, you guys, I gave you a little line graph down here to kind of look at to do. But if you would like to use a different sheet of paper or make some more room, you could totally do that too. So the first thing that I want to do is I want to look at my data and I want to see if it's in order from least to greatest. So 62, 64, 68, 74, these are all in order until I get to here. This number should be written over here somewhere. So because that's the case, because they're not in order there, I'm going to actually have to rewrite my data so that it is in order. So I'm going to start, and I'm just going to rewrite it down here. So I'm going to go 62, 64, which was fine, 68, 74, 80, 84. Then I got to come do this 84. And then I have two 86s. So just make sure that your numbers are in order from least to greatest before you even start. Then what we've got to do is we've got to find the middle. So I'm just going to cross numbers off like I do to find the middle. So here, the last one and the front one gone. Last one, front one gone. Last one, front one gone. Last one and front one are gone. So my median there is actually going to be the number 80 because it's my middle number. Okay. Now I'm going to take off all those lines that I just put on there and let's look at our data set again. Okay, so our middle was 80. I have to rewrite that again. And then we're going to go from there. So let's go and see what else we need to find now. It wants our minimum number. Our minimum is our smallest number, which happens to be 62. Our maximum is 86. So our minimum, our maximum, and our median are what we need. The other things that we need to do in order to find our quartile 1 and quartile 2, and I just want to remind that this was our median. Excuse me, because the median was the number 80, then it broke me into a bottom half and a top half. So this time I don't get to use the number 80 when I'm finding those middle numbers there. I'm only going to use, because it is actually the median, it's the middle. The last example when we did that, we had two numbers in the middle. So the actual median was in between those two numbers, so we could use it in our upper and our lower. But here we don't get to. So what we're going to do here is we're going to find the median of this back part here. So I would cross this one off and cross that one off. And then I'm stuck with two numbers to find the median. I'm going to find the middle of those two numbers. So I would add 84 and 86 together and divide by 2. Or if you can just look at that, you can see that the middle of those two numbers would be 85. So my upper quartile or quartile 3 would be the number 85. Then I'm going to do the same thing with my lower set of data. So if I'm crossing off my highest and my lowest number in my lower set of data, then I'm stuck with two numbers in the middle. And again, I'm just going to find the middle of those two numbers. So add them together and divide by 2. Or if you look at these, it's pretty easy to tell where the middle is of 64 and 68. The middle of that would be 66. So then what I'm going to do here is I'm going to draw my box and whisker plot in order to show it down there on that line graph. So what I think I'm going to do is I'm going to start with my minimum value of 62 down here. And I think I'm just going to, instead of, I'm going to count by 2. So this will be 62. And then, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, and I could keep going and numbering that graph there. I'm just going to leave mine like that because I know my highest number is 86, my maximum, so I'm going to kind of just leave it right there. Okay, I'm going to mark a few spots on this graph that are important. I know that 62 is an important number, it's my minimum. I know that 86 is an important number, it's my maximum. I know that my median is 80, so right here is my middle number. I know that my quartile 1 value is 66, and I know that my quartile 3 value is 85. So kind of right in there just like that. Now all I have to do is draw my box around it. I know that my box's middle is right here, and the box goes to quartile 1 and then back up to quartile 3. Then I know my whiskers go to the minimum and to the maximum, just like that. And so I just drew my box and whisker plot. Okay, so again, I like to find all the data and then put it onto my line graph. So this is my median again, that middle part of my box is the median. This is my quartile 3, this is my quartile 1, this is my minimum, and this is my maximum. And I just have to plot that data on there. All right, next example, same thing. This time I didn't write down the things that we need to find, but we know we first need to put our numbers in order from least to greatest, which is going to take a minute because they're kind of not in order here. So I'm going to start with 46. And then it looks like I have a 47. And then 50. And then it looks like 56. And then 61, 62. $64, $65, $70, $74, $76, $78, $83, and $90. All right, that took a minute to just put them in order. So there's a couple of things that I already know from just doing that though, which is kind of nice. I know that I have my maximum value. My maximum is 90. I know that I have my minimum value. My minimum value is 46. So now I just need to find my median and my quartile 1 and my quartile 3 values. And then I have everything I need in order to draw my box and whisker plot. So again, I just am going to start by finding my middle by crossing off. So not the last number, not the first number, not the last number, not the first number, not the last number, not the first number, not the last number, not the first, not the last, first, last, first. That leaves me 2 numbers in the middle in order to find my median. So 64 plus 65 divided by 2, or halfway in between those 2 points, that's going to give me 64.5 for my median. So that means my median is in between these 2 numbers, which breaks that into an upper part and a lower part. So again, upper part is all of these values, and lower part is all of the other values. So lower part is these ones all the way to the end over here. Okay, so now I have to find the median of those values. So I'm going to change colors here. I've been kind of crossing off a lot, but let's go and do it again. So looking only at the top front values. So not this one or that one. Not the middle here or here, but my middle for the upper quartile is 56. So quartile 1 is 56. Then I do the same thing for quartile 3. I just find the middle of those numbers. It's not 90 and it's not 65. It's not 83 and it's not 70. It's not 78 and it's not 74. It's actually the number 76. So there's all the numbers that I need in order to graph my graph. So again, you guys, I'm just going to label my graph here. I'm going to start with 46 down here and just kind of count up. I don't know. I don't think I have enough room. So let's see. 46, 48, 50, 52, 54, 56, 58, 60. I'm just trying to draw every couple of numbers. 64, 68, 72, 76, 80 would be here. I gotta go all the way up to 90, so I'm just going to kind of pretend that it's over here a little ways, which is kind of off my graph, and I probably need some extra space, but that's where I'm going to stop. So then what I'm going to do is I'm just going to mark my important values on my graph so I can draw my box around it. So I know that my maximum is up here at 90, which means I have a whisker that goes all the way up to 90. I know I have a whisker that goes all the way down to 46. I know that my middle is at 64.5, which is about right here. My quartile 1 goes to 56, and my quartile 3 goes up to 76. So my box goes around those three values with the middle right here. The whiskers go out to the minimum and the maximum, just like that. Questions? All right, let's keep going then. Okay. Now that I know how to draw a box and whisker, I need to know whether or not it's normally distributed, positive distributed, or negative distributed. Meaning, does it skew positive, skew negative, or is it right in the middle? So when the median is in the middle of the box and the whiskers are about the same on both sides of the box, the distribution is symmetric or normal, which would be this one right here. Middle, equal, over here. When the median is closer to the bottom of the box, and if the whisker is shorter on the lower end, so closer, shorter, then it's going to be positively skewed. I kind of like to think about it that more of the box is in the positive side. Then the same thing with the negative. When the median is closer to the top, and the whisker is shorter on the top, then it's going to be negatively skewed. Again, I like to think about it as just more of it's on the negative side. So then the last question says, describe the distribution of the data on the box and the whisker plot. So again, I like to look at how much of the box and the whisker is on more of the side. This definitely has more on this upper side over here, or the right-hand side. Because more of it is on the right-hand side, I'm going to say that this is a positive skewed box and whisker plot. So you're just going to look at some box and whisker plots today and decide what their skew is. All right, thanks for watching, you guys. I hope you can do well on your homework.